is we're going to be using a technique called cross multiplication. And cross multiplication works when you have a fraction equaling another fraction. And so what we can do is we can cross multiply. So in this case, I have a fraction on the left. I have a fraction on the right. So I'm going to go ahead and cross multiply. So that gives me 10 times y equals 5 times 6. And that gives you now 10y equals 30, right? Because 5 times 6 is your 30. We'll divide by our 10. And now we have y equaling 3. And that's all you need to do. That is using the technique called cross multiplication. So cross multiply. 12 is a little bit more complicated. It's similar though. But let's look at 12. Now, whenever we multiply, if we have multiple parts with addition and subtraction, we have to use parentheses. So question 12, we've got x plus 12 over 3 equals x plus 1 over 2. We're going to apply the same technique that we used a moment ago. But on this one, we're going to have to use parentheses because of the addition in this case. So when we write this, I'm going to have to use parentheses. So what we've got is we've got 2 times this quantity of x plus 12. So we put 2 out in front. And then that's going to equal 3 times the quantity x plus 1. So use your parentheses. Okay. And we can finish this by using our distributive property. And when I distribute through, that's going to be 2x plus your 24. And the other side is 3x plus 3. This again is another good review on how to solve equations. So what do we need to do? We need to get our variable x on the left-hand side. And so I'm going to move that 3x over. It's a positive 3x, so to get rid of it, I use a negative. Be careful with your signs. A lot of times where students make mistakes is the simple parts. A lot of times it's just something like missing a sign. So 2 minus 3. All right, 2 minus 3, that leaves you with a minus 1. So that's just a minus x there. We don't have to put the minus 1 in front. We can just use the minus x. And then we've got a plus 24 still and a 3. What do we need to do next? Yep, we'll move that 24 over with subtraction. So we'll take it away. And that leaves me with minus x. And we've got 3 minus 24. Yep, negative 21. This is not our final answer. How do we finish it? Yeah, we divide by our negative 1, right? And then that makes our answer x equaling now what? Positive 21. So are we okay with how I solved that out? Distribute through. Take your time. Watch your signs. Where students make mistakes at more than any other place is with the signs. And it gets frustrating sometimes when you make mistakes and then you start to doubt yourself more. Okay, question 13. I'm not going to work completely out, but I'll set it up and you can finish it. We've got 4r minus 3 over 9 equals now r over 8. Okay, so what do we need to do? We have a fraction equaling another fraction, don't we? When we have a fraction on the left equaling a fraction on the right, we can cross multiply. We need to put the 8 in front, and it's going to get multiplied by 4r minus 3. So we're going to use parentheses here. So we put the 8 in front, and then we have an r minus 3. Inside of there, we use parentheses. And what does it then equal on the other side? 9r, right? And that's it. I think you can finish it from there. Now, 14, 15, and 16 are all looking at proportions and seeing if they are true or false, if they equal each other or not. If they equal each other, when we cross multiply, those numbers should be the same. If they're different, they're not the same. And sometimes this might be something you might want to use to check to see if fractions are equivalent. Because if you cross multiply, they should be the same if they are equivalent. Okay, question 16, we've got 1/2 over 14 equals 1 over 29. Now, we want to see if these are the same or not. We don't have to break them all the way down. All we need to do is see if they are the same. So I'm going to cross multiply. And what does that give me when I cross multiply? Well, that's 29 times 1/2 here should equal 14 times 1. Well, 29 is a 29 over 1. So 29 times 1 is 29. 1 times 2 is 2. What about the other side? That's 14. Okay, does 29 over 2, does that equal 14? No, because 29 divided by 2 is what? 14.5, right? Does it equal 14? No. So this would then be false. Okay, so that's all you need to do is cross multiply, and if they come out to be the same, it's true, they're equal. If they're not, they are different fractions. Sure. Let's see. I don't think that we did that one. Did we? Nope, doesn't look like we did. Okay, we'll go back and do 2.5. You say question number 6? Okay, yep, no problem. I don't think we've covered that one. Okay, we did a lot of them, but I don't think that we did question 6. So we'll go back and look at that one. Okay, question 6. 2.5, question 6. This is another consecutive integer question. So the first thing that we do is we read it. If the first, sorry, that was 5. We're looking at 6. If 3 times the smaller of 2 consecutive integers is added to 4 times the larger number, the result is 53. We want to find the smaller integer. So the first thing I do is I read it, and then let's see what we're working with. Okay, we're working with consecutive integers, and these are not even or odd, so that means the gap is 1. Okay, if it had even or odd, we'd have a gap of 2. And how many of those integers do we need? 2 of them. Okay, so that's where we begin. So the first integer, I'm going to call that x. The second integer, well, that's going to be x plus 1. And they use larger and smaller when they reference these. So let's go ahead and reference ours the same way. The first one is going to be the smaller number. The second one is going to be the larger number. Because you add 1, that makes it larger. Now, what are we doing here? It says if 3 times the smaller of 2 consecutive integers. So let's work with that. 3 times the smaller one. So that would be 3 times the first number, right? Okay, so that's that piece. Now, what's next? 2 consecutive integers, that's those taken care of there, is added to 4 times the larger. So it's added to 4 times the larger. So that's going to be plus 4 times the second number The result is, okay, result is, that means equals. And what does it equal? 53, isn't it? Yep, 53. And we can now plug in our parts. So the first number is x. We'll just put the x there. Second one is going to be 4 times the second number, and that's an x plus 1. That equals your 53. We don't need the parentheses there, so we could rewrite this as this. And I'm going to go ahead and distribute that 4 through as well. So let's go ahead and distribute that through. And that's going to give you then plus, we've got a 4x there, plus 4, and that equals your 53. And I think you can finish it from there. Yep, you're welcome. Does it make sense how I set that one up, though? The more of these we go over, the easier they become. And a lot of times, too, you don't really feel confident in yourself until you do a lot of them. And so that makes it worse. So sometimes you just have to tell yourself you can do this, and I know that everyone can. Take your time. Don't feel rushed. What you don't want to do is get frustrated. So sometimes you may have to walk away for a bit. I know sometimes it can get really frustrating when you start making a lot of mistakes. And at that point, you're better off just walking away, taking a 10-minute break, coming back again. Because that's what I always used to do when I would get frustrated with things, is I would get up, take a short break, come back, and look at it again. And if I was really confused about it, I would normally wait till the next day and try it again then. Okay, so now we're going to go ahead, if there's no other questions, and finish up 2.7. And 2.7 is all about ratios and proportions. We're going to be setting up ratios and we're going to be comparing things. And they're all a little bit different, but all the same. All these is basically setting up division. So when we look at these, I'll pick some of these out of the textbook here for us to look at. Let me get the right section here. We're going to begin with how to set up these ratios. And we're going to start with comparing prices of things. This is something that we don't do as much as we used to because they give you the prices when you go shopping at Walmart or Dillon's. They already have the price tag on there of the comparison. In most cases. In some cases they don't, but let's look at question 25, and this is on page 165. So page 165, we're going to look at question 25. And we're going to be comparing different items. In this case, we're going to be comparing maple syrup. Okay, so we're going to be trying to find our price, in this case, per ounce. And we're going to be finding the better deal. So let me write this up, and then we'll talk about what we're going to be doing here. Okay, $7.99. And we've got $16.99 here. So we went to the store, and we're looking at, in this case, maple syrup. And what the directions say, it says, find the best buy for each item. And it says, give the unit price to the nearest thousandth for that size. So we need to find the price, and we want it to the nearest thousandth. Now, tenths is 1, hundredths is 2, thousandths is going to be 3. So we go past the nearest cent. So we want to find 3 places out. We want to set up a ratio, and we're going to look at the cost per ounce or per size. So how we do that is we set up a ratio, and we want the price over the size. And we're going to look at each item, and we're going to find the one that's the cheapest per ounce in this case. So we take our price, okay, and we divide that price by the size of the container. Anymore, it's already done for you. When you go to the store and you look at those tags at Walmart or Dillon's, that little yellow tag tells you the price per ounce. That's already been calculated for you. but it wasn't that long ago when you had to do it by hand. So how do we set that up? So let's look at these. We're going to take that 8.5 ounce container. Let's see how much it is per ounce. So we take our $5.79. We're going to divide that by the 8.5. And we're going to see what the cost per ounce is. Divide them out. Now, we want to go out 3 decimal places. So that's 0.68 if we round 1. So that's basically 68 cents per ounce. So there's that. Let's do the next one. Let's look at that container that has 12.5 ounces, 12.5. So we've got $7.99. We're going to divide that by the 12.5. And what does that give me per ounce? $7.99. Divide that by 12.5. Okay, that comes out to be 0.639 if we round. And that's per ounce. So that one's almost 64 cents an ounce. So this one would be a little bit better buy than the last one, right? Not by much, but it's a little bit cheaper. And what about the very last one? The largest container. The largest container is $16.99. And we're going to divide that by our 32 ounces. And let's see what that one would come out to be. So we've got $16.99. We're going to divide that by 32. And that comes out to be 0.53 if we round 1. And we want the best buy, so we want the one that's the cheapest per ounce. And that's going to be the largest container. And normally that's true, but not always. In some cases, it might be that the smaller container is a better buy. But most of the time, the larger one's going to be the cheaper one. But that's how you check. So what did I do? I just take the price and I divide it by the size. That's just setting up your ratios. And you always want the smaller one because that's going to be your cheapest price per unit, per ounce, per pound, whatever it might be. So those are pretty straightforward and simple. Next, we're going to look at how to set up the ratios. These are a little bit more complicated. We're going to look at question 55. These are a little bit more complicated, but not really. If 16 candy bars cost me $20, how much do 24 candy bars cost? So we assume they all cost the same amount. We're going to set up our ratio. And our ratio is going to, again, be price, in this case, over the candy bars. So we need to set up our ratio. So we have read it, and it says if 16 candy bars cost $20. So that means we've got our first one, which is $20 we spent. That gives me the 16 candy bars, right? Price over the number of candy bars. That should equal how much we need to spend for 24 candy bars. So what do we not know? We don't know the price. So that's going to be on the top because that's your X. And how many candy bars are we going to want to buy? We're going to try to buy 24, right? So we can label it. This is the price and this is the bars. This is the price and this is the bars here. So I spent $20. I got 16 candy bars. I spent an unknown amount of money. I want to buy 24. So 24 candy bars goes below. How would we solve this? Cross multiply. Very simple to solve once you get to the equation. So now when I cross multiply, I get 16x, and that's going to equal 20 times the 24. 20 times that 24. That gives me the 480. I'll divide by my 16. And that gives you then 30. And that 30 is how much I would expect to spend to get 24 candy bars. So I want to go buy 24 candy bars. That's going to cost me $30. 61. Let's look at 61. Same type of question. If 6 gallons of premium unleaded gasoline cost me $22.56, how much would it cost to completely fill a 15-gallon tank? So let's set up our ratio. I always like to keep the ratio the same, so I'm going to put the price on the top and the gallons of gas on the bottom. So let's set up a ratio. You can do it either order. You can put the gallons on the top, the price on the bottom. It doesn't matter. Just make sure you're consistent. So 61. 6 gallons of gas, $22.56. So I spent $22.56 and I bought 6 gallons of gas. If it helps to label them, you can. If that makes it easier, you can do that. Now, what am I wanting to do? I am wanting to fill up my car. And my car holds 15 gallons. And I don't know how much that's going to cost, so I'm going to use the variable x. Right? We want 15 gallons of gas. And now we can simply cross multiply. So we'll cross multiply and solve this out. So that gives you 6x equals 22.56 times that 15. And 22.56 times that 15. That gives you 338.4 equals that 6x. We'll divide by our 6. And now we've got it, because what's x going to be? Yep, it's going to cost me $56.40. So I should be able to fill up my car with $56.40. Now we're going to do some more of these. They're a little bit different each time, but what we do is we set up a ratio. So they're just setting up a ratio and they're solving them. So these are a little bit different, but let's look at 64. So a researcher at West Okablow Lake tagged 840 fish. A later sample of 1,000 fish contained 18 that were tagged. We want to approximate the number of fish in the lake. And we're going to round that to the nearest 100. So this is how a biologist would go and figure out how many deer are in a forest, or how many wolves there are, or how many, in this case, fish there are in a lake. They capture some, they tag them, they release them, and they go back and they capture some more, and they see how many of those captured ones are tagged, and that's going to give you an approximation of how many fish or how many deer are in a forest. How many fish are in a lake, how many deer might be in a forest. So we need to set up our ratio. And what we've got is we've got the number of fish, and we've got how many fish are tagged. So we need to set up a ratio, okay? And we tagged 840 fish. And then we looked at a sample of 1,000, and 18 were tagged. So we're going to call this the total number of fish, and we're going to divide that total by the number that are tagged. So let's set up our ratio here. Do I know how many total fish are in this lake? No. Okay, I have no idea how many fish are in here. Unknown. So we're going to use an X. Of the total lake, this is my total here. Total number of fish in the lake is unknown. This is the X. This is the number in the lake. Of the number of fish that are in that lake, how many of them did I capture and tag? Okay, 840. So there are a total of an unknown amount of fish in this lake, and I took 840 of them out, and I tagged them, and I released them. Now I go back. Okay, this is going to be the lake here. This side's the lake, and this one's going to be the sample. Then I went back and I sampled. How many fish did I sample? 1,000. And of that fish that I sampled, how many of them were already tagged? Yep, 18, isn't it? Okay, so that's going to go here. So 18 of those were tagged. Now we can cross multiply, and we should be able to get a rough estimate on how many fish are in this lake. So we cross multiply, so that gives you 18x equals 840 times 1,000. So 18x equals now what? 840,000, I believe. Make sure I don't make a mistake with this, but everything looks right. 840,000. Divide by our 18, and now we have an estimate of how many fish are in here. So 840,000, which is what we've got here. Right? We're going to divide that by our 18, and that gives us a rough estimate, and we want it to the nearest what? It says nearest 100. Okay, so the nearest 100 fish. So it looks like we've got about 46,000, and if we round, it looks like 46,000, about 700. We don't have to be super accurate because this is just an estimate. So what I would estimate is there's going to be about 46,000, 47,000 fish in this lake. And that's how they do it. That's how they go out and they sample, and that's how they figure out, okay, how many deer are in this forest? How many bear might be here? They take some, tag them, release them, capture some more, and they record how many of them are tagged. And it's fairly accurate. Let's look now at a distance one. How about 67? They're all setting up ratios. So 67. The distance between Kansas City, Missouri and Denver is 600 miles. On a wall map, this is represented by 2.4 feet. So like that map back there. Now the actual distance from Mexico City to Cairo is 7,700 miles apart. How far are they on the same map? So we want to set up a ratio again. Now it really doesn't matter how we set up the ratio as long as we're careful when we follow it. But when we look at this, we've got two things. We've got miles and we've got inches. Now you could do it either way. I'm just going to put the miles on the top. Inches are going to go down below. And we're looking at Kansas City to Denver. So we'll just say KC here. And we're also looking at the other one is Mexico City. Oh, wait a minute. Make sure I'm on the right one here. Okay. Length of, how many feet would there be between Memphis, right, and Philadelphia? Sorry about that. I looked at the wrong one. that are actually 1,000 miles apart. So then we're going to look at Memphis to Philadelphia. So now let's see what we've got. We're going to make this ratio miles over inches. So what do we have? The distance between Kansas City and Denver is 600 miles. So that 600 is going to go here on the top. That's miles. And on a wall map, that is 2.4 feet. Sorry about that. That's feet. I was looking at the next one. My mistake. That's feet. Okay, so that's going to be in feet there. Is everyone okay with that? Kansas City, 600 miles, 2.4 feet. Then we look at Memphis to Philadelphia. Now, Memphis to Philadelphia is 1,000 miles, and what we need to find is how far they are on the map. So that's going to be your unknown, and that's going to be the variable x. Is everyone okay with how I set it up? Now we just cross multiply. Okay, and we'll do that. So that's going to give me 600x equals 1,000 times 2.4. So that's going to be 2,400 there. Equals that 600x. Divide by our 600. And that should leave you with 4, I believe. Yep, I can always double check myself while we write that down. So 2,400. We're going to divide that by your 600. And that comes out to be 4. So on the map, that would be 4 feet. What we always do is we set up a ratio. It doesn't matter which one goes on the top, which one goes on the bottom. You could put the feet over the miles. That's okay too, as long as you're consistent. Let's look now at 71. On a world globe, the distance between Cape Town and Bangkok is actually 10,080 kilometers apart, and that is 12.4 inches. The actual distance between Moscow and Berlin is 1,610 kilometers. How far apart are they on the globe? So again, we're going to set up a ratio. Doesn't matter how we set it up, but I'm just going to make it as kilometers over inches in this case. So kilometers over the inches is going to be my ratio. And we are looking at Cape Town. And we're looking at Moscow to Berlin. And so the distance from Cape Town to Bangkok, that is 10,080 kilometers. And on a globe, that is 12.4 inches. And Moscow to Berlin is 1,610 kilometers. And that is represented by an unknown number of inches, x there. Now we've got the ratio. We can simply cross multiply. And that gives me now 10,080x, and that equals 1610 times 12.4. 1610 times that 12.4, that comes out to be 19,964. And we'll divide. And we're going to have to use a calculator here, so we'll go ahead and divide that out. Okay. And that then gives me an approximate distance of, how far do they want us to round? It doesn't say here. They rounded the nearest tenth, so we'll keep it to the nearest tenth because they got 12.4. So we'll round this nearest tenth. So it looks like it's about 1.98 or about 2.0. About 2 inches on that globe. So all we did was we set up a ratio. That's it. 74. 74 is something you may have to do. 74 is setting up a ratio so that you get the correct concentration for floor cleaner. So question 74. The directions on a bottle of Armstrong floor cleaner specify that for extra strength cleaning, a half a cup of cleaner should be used for each gallon of water. How much cleaner should be mixed with 15.5 gallons of water for that extra strength cleaning? So maybe I have to fill up a floor machine, and that floor machine holds 15.5 gallons. I need to make sure that I use the correct amount of cleaner for that floor machine. So we need to set up our ratio. And what are we doing with this cleaner? Okay, we're going to be diluting it with water. So I'm going to set up my ratio as cleaner over water. Okay, that's the two things we're looking at. Cleaner over the water. So let's start looking at our directions. Okay, the directions on this cleaner say that it is a half a cup of cleaner for each gallon of water. And the cleaner is in cups, and the water is going to be in gallons. So the cleaner over the gallons of water. So when we look at the cleaner, our first ratio from the directions is a half a cup of cleaner over 1 gallon of water. So the directions tell me that it's a half a cup of cleaner, right? 1 gallon of water. Now, we need to fill up this floor machine. And this floor machine has got a lot of water it needs. And this floor machine needs 15.5 gallons of water. How much cleaner am I going to have to use? Well, we don't know. So we're going to use an X. Is everyone okay with how I set that ratio up? Now, this one has the fractions. We're going to have to deal with those. But we're going to do the same process. We're going to cross multiply. And the fractions will have to convert to a mixed fraction, improper fraction, so that we can multiply. So that gives me X equals now 15.5 times a half. It has been a while since we've talked about mixed and improper fractions. If I want to multiply these fractions out, I need to convert this. So let's convert this 15.5 gallons into an improper fraction. And how would I do that? Well, it's going to be over 2, and we take our 15 times 2, add 1 to it. So that 15.5 is actually 31 over 2. Is everyone okay with that? Remember, multiply it by the number down below, add the number on the top. So 15.5 is 15 times 2, which is 30, plus 1 makes it that 31. Now we can finish it. Okay. So now we can go ahead and multiply, and that gives me 31 over 4. And let's convert this down into something that we can work with. So we need to know how many cups we're going to need. We're at 31 over 4. And what would 31 over 4 be as a mixed fraction? Okay, well, let's take our 31, divide that by 4. What is that? 7.75. So that's 7. So 31 over 4 is going to come out to be 7. And then what's my remainder? Okay, 31. 7 times 4 is 28. So 31 minus your 28, that makes it then what? 3. So that's 7 3/4. So what do I need? I need 7 3/4 cups. And you could also use decimals and convert them back, either way. Right, because 7 times 4 is 28. We've got 31, so I took it away. That gave me that 3. Okay, so what I did was I need to figure out what my whole number is. So I've got this 31 over 4. So let's use our calculator. And that comes out to be 7.75. Okay? So that means my whole number out in front is going to be what? 7. Now, where did the 28 come from? Well, the 28 came from 7 times 4, which is 28, right? Now, I'm going to take my 31, which is my numerator, and I'm going to take out the 7 times the 4, which is out in front, which is the 28, and that leaves me then with a difference of what? 3. So that's my remainder. So that would come out to be 7 3/4 of a cup. Or you could look at it like this. If I just use my calculator, it's 7.75, right? What would that be as a fraction? Well, 0.75, that's 3/4 of a cup, right? So it's the same thing. You could look at it either way. You can either use your calculator like I did here, or you could work it out like I did over here. Either way, when I'm done, I'm going to have to go back and I'm going to have to pour 7 3/4 cups of cleaning fluid. And that should make sure that the machine has the correct strength, that we were not wasting any chemicals. But you could look at it either way. You can use the decimals if you prefer, or you can use the fractions. But the one thing you have to remember is when you multiply fractions, if this is a mixed fraction, to multiply it, you've got to turn it into an improper fraction or a decimal. Either way. You could have turned this into a decimal and just multiplied. Right? Because I could have done this. I could have said, okay, 15.5, well, that's 15.5. I'm going to multiply that by half, so that's 0.5. And I would get the same thing. Either way you want to look at it. Uh-huh. Right. Okay. Where I did that was I took the 31 times 1. Okay, that's a 1. And 2 times the 2 down below in my denominator. That makes that 4. Okay? Yeah, and you can use decimals if you want on these two. Doesn't matter. In this case, if you think about it, if you were going to go ahead and fill up that machine, you would probably convert that back to a fraction. Because if you were going to actually fill this machine up and you go pull up the container, that container is going to be, 1/4 cups. You're not going to have 0.25. So I would go ahead and convert that back to fractions. Okay, pretty easy to do, though. That one's a simple one. And they're all pretty much like that. I mean, it's a common fraction that you're going to use. So I would just convert that decimal back to a fraction. That way, if you're actually going to do that, you'll make sure you pull out the correct amount of cleaning fluid. Okay, let's look at another one of these, and then we'll take a short break. Let's look at currency transactions. How about question 76? So we're going to exchange different currencies here. And again, we're going to set up a ratio. These are not difficult. And they're actually kind of fun to do because it's simple. Question 76. If $8 can be exchanged for 150.775 pesos, how many pesos can I get for $65? So I want to do a conversion here. And we want to round to the nearest tenth. Doesn't matter which one goes on top and which one goes on the bottom. We just have to make sure that we are consistent. So how about we use dollars on top and pesos on the bottom. So I've got $8, and if I have $8, that converts to 150.775 .775 pesos, right? So $8 gives me almost 151 pesos. Now, I need to convert some more. So now I need to convert $65. So I want to spend $65, and I want to see how many pesos I would get. Well, do I know how many pesos I need here? Nope. So that's going to be my unknown. And now I simply cross multiply. And that's going to give me now 8x equals 150.775 times my 65. So simple enough there. 150.775. We're going to multiply that by 65. And that gives me 9,800.375. And that's going to equal 8x. Divide by our 8. And how many pesos do I get now? I'm going to divide that by my 8. I end up now with 12,000. Or sorry, not 12,000. I can read right here. 1,225. And it says round to the nearest tenth. So it looks like it's going to be, about 1,225 pesos. Round to the nearest tenth here. So that's what we're going to have for the number of pesos. Let's take a short break. We'll come back and we'll finish up this section. And then we'll probably start the next one as well.